Challenge 5. In this video, we'll talk about operations with sheet metal, but also we'll talk about the appropriate welding for each of the pieces in which we have focused. The first example are main landing gear doors. The appropriate materials to design most of these part features are CFRP, which compose 52% of it, and the rest is conformed by metals which can be easily manufactured by sheet metal operations such as aluminum 38%, steel 3%, and other 6%. We'll focus on the sections made out of aluminum. To create the aluminum features, it is necessary to apply the sheet metal operation known as bending. It is a very useful process because it allows the user to deform the piece at will. In this case, the shapes are the objective, so it is just a matter of following the right steps to give the sheet the desired form. Formability of the material plays an important role. We consider it is important to specify the weight because this part should be able to open in an emergency situation, but also that the material can stand the temperatures that coexist when flying at hundreds of feet away from the surface. The material should be strong enough to manage the pressure reached during flying operations. Aluminum 6061 T6 can be welded with 4 common filler alloys as well as several specialty alloys. This one has a very good corrosion resistance and finishing ability. Welding goes well without any problem. These are versatile heat-treatable alloys that, when annealed, offer a satisfactory difference between yield and tensile strength and good elongation. Their bending ability will decrease. However, when you move to T4 and T6 tempers, my recommendation therefore is to bend in T4 condition and then heat treat to T6 if this is possible. The bliss blades are a turbo machine component comprising both rotor, disc, and blades. It consists of a single part, instead of an assembly of a disc and individual removable blades. Bliss may be additive manufactured, integrally cast, machined from a solid piece of material, or made by welding individual blades to a rotor disc. Historically, the material used in the manufacture of bliss blades has been IC403 or IC403 plus CB stainless steel, both with 12% Cr ferritic, due to its ability to form a durable passive film and its inherent resistance to stress corrosion cracking. 403 plus CB is a suitable material to be used in neutral and alkaline environments, where the corrosion of carbon steels would involve a continuous maintenance cost. The best way for bliss blades to make the most of their capabilities is the milling process, since manufacturing it using this technique offers a high level of precision in its finish that allows the material to offer full use of its properties. Titanium is perfect for its high resistance to temperatures, friction, and for being light for air vehicles. These characteristics allow the blades to perfectly fulfill their mission. To join the blades with the bliss, they go through a process called linear friction welding, which consists of a machine that joins the two ends to be joined and rubs them from top to bottom at a speed so fast that it melts the parts to be welded internally and not only external as it would be by laser welding, helping to make it totally fixed and attached to the bliss. The advantages of this type of welding is that it perfectly joins the pieces in such a way that they always were only one. The only drawback is that, due to this, errors should not be admitted since it is almost impossible to rejoin the piece that does not be done from scratch. Talking about heat treatments involved, for this, you have to calculate well the time and intensity of the heat generated within the friction process, since if the weld is exceeded or reduced, it can generate a piece with inefficiencies or even ruin the piece itself.
The wings of an aircraft generate most of the lift to hold this giant metallic bird in the air. These are composed of two principal parts, the skeleton and the skin. The skeleton or frames are made with aluminum alloy 7075, which is a combination of aluminum and zinc, which has high mechanical properties and improved stress corrosion cracking resistance. And the skin is made from two metals. At the top of it, it is made of aluminum alloy 7178, which is a combination of aluminum, zinc, magnesium, and copper, which has high mechanical compressive strength to weight ratio. And under it is made of aluminum alloy 7055, which is a combination of aluminum, zinc, magnesium, and copper, which has a superior stress corrosion. Now we're going to talk about the processes involved at the manufacturing process for the aluminum sheets. After aluminum is extracted, it is melted and poured into different forms that produce sheet ingots or slabs, which are then used to create aluminum plates and sheets. In the production of aluminum plates, the sheet ingots or slabs are first smoothed to get that mirror-like shine that aluminum is known for. These are then rolled through a rolling machine after being heated to 400 Celsius degrees, and this comes out as a thin sheet of metal. This process is called hot rolling. The next stage for these aluminum sheets is called cold rolling. This is where these sheets are flattened into different thicknesses to suit the many applications like aircraft wings. And finally, processes like baking to strengthen the aluminum, machining, and punching are made to get the final product. If we are going to choose the material, we will care about the grain size because it is one of the key microstructural factors that affect the properties of aluminum alloys. Fine grains generally result in isotropic mechanical properties, reduced porosity, and a strong material. Also, the material should be able to reach a smooth surface. One reason of why aircraft wings are manufactured with riveted joints instead of welded joints is because the aluminum materials used in their construction isn't tolerant of heat, but aluminum becomes weaker when exposed to heat, including the heat from welding. So most aerospace manufacturing companies prefer to connect joints using rivets. The greatest benefit of using riveted joints in an aircraft is that they are stronger and more durable than welded joints. When two components are welded together, only the exterior of these components are joined together. On the other hand, using a rivet connects the two components from the inside, thus allowing for a stronger and more durable joint.